Greetings and welcome to the fascinating world of the integration. In this video lecture, we will understand why we will add the concept of integration after integrating any function. So we will understand and grab the concept. So as we know that there are two types of integration. One is definite integration and another is indefinite integration. The one having upper limit and lower limit called definite integral, and in any indefinite integral, the after integration the constant of integration applies with the integrated function. So we will add the constant of integration symbol C after integrated function. So here also we know that the integration and differentiation are the reverse processes of each other. This is the symbol of integration. If we integrate x with respect to dx, so the answer will be equal to by applying the power rule, the answer will be x square divided by 2. Then we will add this plus c, constant of integration. So the whole video lecture is about this, why we will add the constant of integration after integrated function. This is the integrated function, means the function which the answer after integration. This is the function x. If we integrate this function x with respect to dx, then we will get this answer. Here this is the general form. Why we will add this function c? If we integrate this function, then this c we will add. The value of c will depends upon the boundary condition. If we apply the boundary condition, then the corrected value of c will be becomes. So here we don't know the boundary condition, so we will generally put the value c. As we know that the integration and differentiation are the reverse processes, we will prove that the integration and the differentiation are the reverse processes. If we differentiate this function with respect to x, then the answer should become equal to this function x. Because we said that the integration and differentiation are the reverse processes. If these both processes are reverse, then the differentiation of this will be equal to this function, and the integration of this function is this, so the reverse processes will be this function. Remember, this is the concept of differentiation. If we differentiate this function with respect to x, then the answer should become equal to this. So now we will look and differentiate with this function with respect to x. So this is d by dx, the symbol of derivative of x square divided by 2 plus the derivative of constant with respect to x. So we will look the differentiation of x square by 2 plus constant. So the derivative of x square divided by 2 is 2x divided by 2. The derivative of x square is 2x, remember. Then the derivative of constant is 0, because we by fourth step by principle ab initio we know that the derivative of constant is always equal to 0. I have made a video lecture, separate video lecture to prove that why the derivative of constant is 0. So watch this video in my playlist of mathematics. So this is the derivative of x square with respect to x is 2x, and the remaining 2 is in denominator is this. So this is 2x plus 2x divided by 2, then the derivative of constant is 0. So I will put 0. So this 2 and 2 will cancel out, so the answer will be x plus 0. So x plus 0 will also become equal to x. So this is the answer of this whole procedure. So you can see that this x is equal to this x, because we say that the derivative and integration are the reverse processes. I derivate this function, then the answer become equal to the first, as we mentioned that integration of x. So these both are reverse processes, we prove that. Now the question arises that why we put this symbol c. If I differentiate x square divided by 2 plus 1 with respect to x, then the answer should also become equal to this. and instead of 1, if I put 100, then the answer remains same x. After differentiation, the answer remains same. If in place of 100, if I put any value, any constant value, 8, anything 8, if we put any constant value, then there will be no effect on answer. After differentiation, there will be no effect on answer, so the answer remain x. That's why we put the instead of constant, we put the value this. Instead of 8, we put the value c. Remember this is the concept behind the adding the value of c, constant of integration symbol c. So this is the whole gist of this concept. If we did not put this symbol c, then the answer of this integration is not complete, so there will be a cuttage of marks. So this is very important. And remember this, if we differentiate this function with respect to x, then the answer become equal to this initial function as we integrated. So this function, the derivative of this function will become equal to this, and the integration of this symbol, this function will become equal to this. So these are the reverse processes. In integration and derivative are the reverse processes. So after integration, we will put the symbol c before integrated function. This is the integrated function. So remember this is the whole gist of the concept of integration. So this c value, the corrected c value, comes from the boundary condition. So thanks to all.